This is a core chemistry specified practice looking at how temperature affects the rate of reaction. So here's the method. If you want to read the method fully, then pause now. Here's a diagram of a person completing it, and there's a couple of tips that you might want to use, and then there's a hazard up here. So if you're interested or want to have a quick look, there's your hazard, health and safety at the top here, and there's a method. But the first thing we're going to do now is watch a demonstration of this prac taking place.
Okay, so another specified prac here now. Again on the rates topic, but now we're looking at how temperature can affect rates. Okay, so the equipment we've got today, we've got a water bath, and we would have more water baths normally to have your different temperatures. I've got a beaker, piece of paper with a cross on. I've got 2 measuring cylinders. I've then got some hydrochloric acid, some thiosulfate, and a stop clock. Okay, and the whole idea behind this is we're going to have a reaction between the thiosulfate and the hydrochloric acid. It's going to form a precipitate, so it's going to go from being clear to now being cloudy, so we're not going to be able to see that cross at the end. Now, just thinking of ways to improve this and make it more accurate would be to use a colour change remitter rather than the eye, because you never know, you could get distracted and miss it, or you could just be thinking that the reaction is continuing when it's not. So first thing I'm going to do is I'm going to have 50 millilitres of thiosulfate, and again I'm just going to get down low. I'm going to make sure that I'm not falling fate to any parallax and I'm observing it from my level. Okay, and I'll pour that into my beaker, and I'm going to place my beaker on the cross straight away. And my next thing then, I'm going to measure out 5 of 2 molar hydrochloric acid. Okay, and again, just make sure you're down. Quite hard to measure H5, isn't it?
Yes. Should use a pipette.
So that's another way we could improve this then. Pipette, and that's bang on there. Okay, now the next thing which I'm going to do, as soon as I add this hydrochloric acid in now, I'm going to start the stop clock. Okay, and then give it a swirl to start the reaction going. That's in there. Start it going. And then it's just a waiting game then. Okay, so just while that's going on now, I've got the stop clock running. I'll just run you through what we would do next. I'm doing room temperature at the bottom, and then going to repeat at 40, 60 and 80. Obviously I can't go much higher than that because it's a solution, so it'll begin to boil. And we can actually see the temperature beginning to change. Okay, temperature, the colour, sorry. And it's
So
not
once you can't see the cross through it, you've got to stop your stopwatch. So I reckon you're...
there.
Yeah.
And then I will record that then into, where's that table? And I've used 0.26 because my digital stop clock is precise enough to do to that resolution.
So looking at that then, you would then take that table of results and plot the information again into a graph. So I have done one for you. If it's an exam, you must be provided with the data. So you've got temperature running along the bottom, and you've got time taken for the cross to disappear running along the top. And as you can see, I've got a curve again. So as temperature increases, time decreases at a decreasing rate. Okay, it is so important that you remember these different ones, because that's 2 marks in the exam, and that's the difference between grades. So that's the first thing you might be asked to do, is plot a graph and describe what your graph is showing you. The other thing then you might be asked to do is give a explanation of to why this happens. So higher temperatures, particles have more kinetic energy. Remember, kinetic energy means movement energy, energy that causes them to move. This means they are more likely to collide, leading to a higher frequency of successful collisions. Remember, particles are always colliding. It's the successful collisions that you want. That will then lead to a quicker rate of reaction, hence the quicker time. A couple of things you can do with this experiment to improve inaccuracy or accuracy. One of them is a colour meter or a light intensity meter. So instead of using your eye to notice when the colour change takes place, you can use equipment which will be more accurate. High resolution equipment, so when we were using the measuring cylinders, we could have used something called a burette and a pipette. It would have just given you a higher resolution, making your results again more accurate. With the swilling, you need to either swill constantly or not swill at all. And there's also equipment that you can use again to make that more accurate so that every time you're doing a swill, it's exactly the same force.